Good morning, students. Today we are taking a new very important topic, that is projectile motion. Basically, what is projectile motion? See, if you have a ball in your hand and if you are throwing it, if you are throwing it straight vertically upward, then it will come down straight. But if you throw the ball like this, that you are throwing it from point A and reaching to some distance, covering some height. So here it is following some curved path. This is an example of projectile motion. Likewise, suppose you are standing in a building, right? And from the top of the building, from your this particular highest point, let we are throwing any body, a ball, any body. When it is following this curved path, this is also an example of projectile motion. So basically, projectile motion, it is dealing with the motion in which path of the motion that will be somehow parabolic, a curved path. So now here we are using a term projectile. Basically, what is this projectile? It is a name given to a body. Actually, this is nothing but when a body, when it is thrown with some velocity, this we term it as projectile. So it is a name given to a body thrown with some initial velocity. This is the initial velocity which we are giving to it. So now a body which is thrown with some initial velocity at an angle with the horizontal. If it is thrown with some velocity u making an angle with the horizontal, then it is allowed to move in two dimension. Two dimension means it is moving this horizontal distance, it is covering this horizontal distance, as well as you can see its height, its vertical distance is also changing. You can see it is at this point, at the starting point, reaching to this, that means at this particular point it has covered this horizontal distance, this vertical distance. At this particular point, now the height is increased as well as horizontal distance is increased. So depending upon the different positions, it is moving in both the directions, and this is under the action of gravity alone. So basically, projectile, it is a name given to a body thrown with some initial velocity at an angle with the horizontal and then allowed to move in two dimension under the effect of gravity alone. This is the term we will give to projectile. Now, what is trajectory? Trajectory, it is nothing but a path. It is the path followed by a body or a projectile. This is taken as the trajectory. So what can be the more practical examples of projectile motion? So a body dropped from a window of a moving bus. Suppose there is a bus and there are windows and the passenger are sitting inside it. Suppose they are throwing something outside, it will not go straight but it will follow this curved path. We have introduced this concept in kinematics when we were discussing the general starting point, that when a ball, when it is thrown outward from a moving train or a bus, it is following the curved path. Similarly, if you are firing a bullet from a rifle, it will not go straight, it will move along a curved path. And when you are opening your tap, a jet of water rushing out from the side hole of a vessel. Suppose here is a small hole and here it is in a tank, there is a water filling it, and when you are just opening the tap from here, it will not go straight, it will follow this curved path. Similarly, there can be many more examples that can explain this projectile motion. And suppose an aeroplane is flying and from it, if a food packet has been dropped or any object is thrown from this aeroplane, again it will follow this curved path. So there can be many more practical examples of projectile motion. This topic is quite important and interesting because you can realize many different physical situations in your surrounding with this kind of motion. So now let me start discussing this basic description. Now, if a body is projected making an angle theta with the horizontal, if a body is projected with certain speed making an angle theta with the horizontal and it is following this curved path, this is termed as oblique or angular projection. Means body has been projected at some angle. Whereas when the body is projected horizontally from certain height and then it is again moving under the influence of gravity following this path, this is horizontal projection. So we will discuss these two one by one. One important point which we have to learn, that in projectile motion, this projectile move under the combined effect of two velocities. Here two velocities are there, that is uniform velocity in horizontal direction. Body, either of the two projectile motion we are taking, that here horizontal component of velocity that will always remain to be same, either this or this one. So one point you have to understand, I will explain it while we will derive these. So uniform velocity in horizontal direction, that means velocity along the horizontal which will never change, it will remains to be constant. Whereas second velocity, that will be changing, this will be vertical velocity, vertical component of velocity, and it will keep on changing. So it means projectile move under the combined effect of two velocities. Horizontal velocities remain same at every point, whereas vertical component of velocity changes its value. Now here we are taking few assumptions. What are the assumptions? As there is no air resistance, we are not considering the effect of air resistance. Like we have also done it in straight line motion. Suppose a ball is thrown vertically upward, we have taken time of going up and time of coming down is same because we have ignored the effect of air resistance. So same result we are using there, where here also we are not considering the effect of air resistance. Second, the effect due to rotation of earth and curvature of earth is also neglected. It is negligibly small. We will not consider the effect of rotation of earth and curvature of earth. And acceleration due to gravity along vertical direction. Actually this G is acting always along vertical. There is no component of acceleration due to gravity along horizontal. So acceleration due to gravity, this is constant both in magnitude as well as in direction. So these are the few assumptions which I am taking before going to the particular part, that is either horizontal projection or oblique projection. So we have to just remember that all these points, that the body when it is projected move under the combined effect of two velocities, and these will be the assumptions. So first of all I am taking horizontal projection. So for it, let a body is projected from a height h with horizontal velocity u. Body is projected from the top of this height, that is top of a building you can take, top of a tower, that can be any height which has been given here. So a body is projected with horizontal velocity u from the top of a height h. Then object move under the combined effect of two perpendicular velocities, and it will follow this curved path. So what are the two velocities? That is horizontal velocity u, this will be remaining constant, and vertical velocity which will increase due to the effect of gravity. Now if we consider initial horizontal velocity, that is u, and initial vertical velocity is 0, because it has been clearly mentioned that a body is projected with horizontal velocity. It means no component of vertical velocity is present here. So now first of all we have to study its path. What is the kind of path? That means we have to derive an equation which will fulfill the condition of this motion. So we have to study here path of projectile. Let me take P be a point any instant of time having x and y coordinate. xy. Let x coordinate is, this one is the x coordinate and this one is the y coordinate. So after time t, after from the projection from the height, let it is reaching to point P. So now within this time, what is the horizontal distance covered? Horizontal distance covered, we simply use s equal to ut plus half at square. See, here we are using only horizontal direction, so we can use it as x coordinate is x, that is for this point P the x coordinate is small x, so I will use this one. X will be equal to uxt plus half axt square. Now ux is u, it is given. Ax, I have already explained that there is no component of acceleration due to gravity along the horizontal. So here what I will get, x equal to ut. So from here we can obtain the time instant that at which we are discussing the path. Right? So we along horizontal direction we have find horizontal distance covered, from where we have obtained the time. So at the same time, let we find what is the vertical distance covered. So vertical distance covered. What is the vertical distance covered? So vertical distance is y equal to uyt plus half ayt square. Now what will be uy? As body is coming downward, so its velocity, now you see, first of all you will see that vertical component, initial vertical component of velocity is 0. Now I will say that as the body is coming vertically downward, so acceleration due to gravity will be g, it will be positive as per the convention. So now use the values here. First term will be 0, second term will be plus half gt square. Now y we have taken to be half g. Substitute the value of time from this equation, so it will be x square upon u square. Now see, y equal to g by 2u square into x square. See this term, g constant, u speed constant, so y equal to kx square. It means now this is the equation of parabola. It means, hence we can say that path of projectile is parabolic. Right? Basically, here in this part, what kind of question can be asked? You can see here question can be, prove that path of horizontal projectile, horizontal projection is parabolic, or discuss the motion of projectile in horizontal projection. What will be the equation of motion? What will be the equation of trajectory? This can also be asked. What can be the equation of trajectory when a body is in horizontal projection? So there can be different kind of question. Basic point that here we have to obtain this equation, and equation, if it is in this form, this is representing parabolic equation. Now for this horizontal projectile motion, what is the time taken by projectile to move from the starting point A to point B, that is on the ground? So this is termed as time of flight. Time of flight, let me represent it by capital T, and it is the total time for which projectile is in air. Basically, air means that total time for which it will remain in air, or total time taken by projectile to cover this motion. Or in a simple way you can say it is a total time for which projectile is in flight. That means it is in motion along this path. So now to calculate it, again let me take vertical motion. Here equation of motion you are using. You have to choose which particular equation is suitable. Here, as vertical distance is h, initial vertical speed is 0, and ay is g, and time taken to reach at point B is capital T, from point A to B. So now substitute the values. H is half g t square. So t square will be 2h upon g and t will be under root of 2h upon g. So this is the time of flight we have taken for horizontal projection. Now, when a projectile has taken some time, so what is the total horizontal distance covered by a projectile? So let me take it as horizontal range. Let me take as capital R. So how can we define? It is the horizontal distance covered by a projectile during the flight. That means when it has started its motion from A, so actually what is the horizontal distance OB covered by the projectile? So basically you can see here again that it is in the horizontal direction. So you will apply here equation motion along x-axis. Equation you will use like this. Here ux is u and ax will be 0, and let me take this x to be r, because maximum horizontal distance, that is not maximum, you can take it as the total horizontal distance covered. So it is horizontal range is u into t. Yes, t time is equal to capital T. So basically here u into under root of 2h upon g, this is giving you the horizontal range. So these topics are quite very simple. Basic concept you have to learn, that how we are considering motion along horizontal and vertical direction. Now let me discuss velocity of projectile at any instant. See here, as a projectile is thrown, so what is the velocity at any different instant? If we take here on the path, the velocity of projectile will be different. Let we are taking P be a point at any time t. Let V is the velocity at this instant. So here if we take that this velocity, let it is making an angle beta with the horizontal, and this component will be Vx. This is the horizontal component of velocity, and this perpendicular component will be Vy. So here Vx and Vy are the two components, rectangular components of velocity at any time t. We have to calculate these two values in terms of given parameters. So first of all, let me apply the equation, as we have to calculate velocity corresponding to time. So we will prefer to use the equation V equal to U plus AT. As Ux is U, Ax is 0, so Vx will be U. Now you can see I have started it from the very first topic, very first point, that horizontal component of velocity, it will always remain same. It means at any instant you will take, this horizontal component will always remaining to be U. Why? Because this factor can only change by this factor, by this axt. As there is no acceleration due to gravity along the horizontal, so no factor is responsible for changing its velocity. Similarly, if we have to calculate vertical component of velocity, so we will use the equation Vy equal to Uy plus Ayt. So again, Uy initial vertical component of velocity is 0 and Ay is g. So now you can see here that vertical component is changing as per time t. See, acceleration due to gravity will be remaining same along the vertical. It is the time. At different instant of time, this vertical component will be different. You can see, suppose at this point, you are taking the point here, you are taking the point here. Suppose after 1 second you are calculating. So as the time will increase, the vertical component of velocity will also go on increasing. Okay. So what is the velocity? Velocity will be under root of, actually we are taking magnitude of velocity or speed. So it will be under root of u square plus g square t square. This is the magnitude. Now what will be the direction? Whenever we are taking the velocity, it means we have to calculate magnitude, as well as direction. So for its direction, tangent beta, see, you can see here in this triangle, you can either take triangle or directly you can see it. The tangent beta will be this perpendicular component upon horizontal, and this perpendicular component is Vy and horizontal is Vx. So here it will be Vy upon Vx, that is Gt upon U. So you can leave this result at this particular point, or if you actually want to find the value of this angle, then it will be in terms of inverse function. You can write it in this term. So this is all about horizontal projectile. So whenever horizontal projectile is asked, so basically what can be the 4 questions on its basis as on its derivations. Firstly, equation of trajectory, that is path of projectile. Second, time of flight. Third, horizontal range. And fourth is this one, that is velocity of projectile at any instant. So revise it, practice it, because on this basis direct derivations are important, as well as later on we will discuss its numericals.